Right, now this worksheet is isotope calculation worksheet. So we want to find out the average atomic mass from the percentage abundance of isotope. So we have a lot of isotope, okay? Actually the atom one will be the most abundant, meaning the most percentage, and then we have some other isotope will be less percentage. So by comparing their percentage, we multiply everything all together, we can find the atomic mass. So there is a formula here. We're taking the AMU times percent abundance, all right? But we don't want to put percentage in the calculator because I don't want to see percentage. So we will change percentage to be relative abundance, 0 to 1. Okay? Make sure that you round the answer is 2 places. So we want to find the atomic mass for Li. Now here we can tell that it's actually 2 different information. Okay, so we underline one with one color. All right, so here is we list it out. So the first one is 6 Li. Now the 6 here meaning mass number. Okay, so the formula is AMU. Okay, 6.015 thing, right? AMU, make sure you underline AMU, times 7.5% is actually 0.075. You move your decimal point 2 to the left hand side. All right, and then you multiply that, and then 7Li will be taking the AMU and then multiply 92.5%, which is 0.925. You multiply them, you get this. Now make sure that you add these two numbers to see if it's equal to 1. If it's not equal to 1, no matter how you do it, you will not get the right answer. Okay, so make sure you add the numbers, the relative abundance equal to 1, because 1 is actually 100%. And after this, you add these two numbers to get 6.94, 0.9379666. And then you round your answer to be 2 places. And the 6.94, AMU is the unit, and lithium is the symbol. Now, if you look up the lithium on the periodic table, 694 is the atomic mass. Okay, so if you take the AMU, multiply the abundance, and then you add up all together, you will get the average atomic mass on the periodic table. Okay. Now, number 4 at the back is actually more than 2, or we can have 2, 3, 4 isotopes. So it's the same math. We take the AMU times the relative abundance. Okay, so we got 3 different isotope information. Okay, so each of them, AMU times the percentage, but we make sure that this is a relative abundance and make sure that these 3 numbers add up to 1. We add them all together and it's equal to 24.31 AMU mg, which is the same number as the periodic table. However, there's sometimes this number will be off a little bit. So for example, this one, my AMU from the calculations 152.04, but my AMU from the periodic table is 151.96. This is close enough. This is a good answer because we still actually have other isotope has a very, very small percentage. Very, very small percentage. So it will off a little bit. So this one, I would say these two, if the difference is less than 1, that will be fine. Now this question do not have AMU. You see that there's no AMU, so how will you find it? So remember the AMU, if you round this number, will become 26. You round this number, become 25. You round this number, become 24. Actually, the AMU, if you round it, is actually the mass number. So if in the question they did not give you AMU, you can actually just use the mass number. Okay, so if there's no AMU given, just use the mass number and add the AMU. You see that if you get a 26, you round it. This one, you round it to that. This one, you round it to that. This one, you round it to that. So you can use this number if there's no AMU question, no AMU information. You just take the mass number and put the AMU on, and then do the same math. Okay? And then number 7, this one is actually homework. You want to do it on a separate piece of paper, write down the question, and then show the math.